Okay, this is exam 2, fall 25. From ground level, you kick a ball with a mass of 4 kilograms. It goes up and then it comes back down again. I give it an initial velocity of 22 meters per second, and then it returns back to ground level. And the angle here, I tell you, is 60 degrees. I want to know the speed of the ball at the top of the trajectory. First, let's just find v naught x and v naught y. I like to do this right off. V naught x is going to be 22 cosine 60, and then v naught y is equal to 22 sine of 60. So these are 11 and 19 meters per second. Uh, and then for the speed at the top of the trajectory, it only has a velocity in the x direction. It has no velocity in the y direction, and that velocity in the x direction is equal to v naught x. So for part A, the velocity at the top is going to be equal to that v naught x, which is going to be 11 meters per second. So I've already found that. I just found the x component of the initial velocity. What is the maximum vertical range of the ball? That is, how high does it go, the vertical range? So the first thing I want to do is find the time at the top of the trajectory. I know that Vy at the top is equal to 0, and Vy at the top is equal to V naught y plus Ay times T top. So that's 0 equals 19 minus 10 times T top. Solve that for T top. I get 1.9 seconds. So that's the time when it reaches up here, 1.9 seconds. So if I want to know the vertical range of the ball, I would just say that y is equal to v naught y times t top plus 1/2 ay t squared. That's 19 times 1.9 minus 5. That's half of negative 10 times 1.9 squared. I get 18 meters. Right, so that's the vertical range. That's the velocity at the top and the vertical range. And then at 2.5 seconds, which is going to be somewhere right here, I want to know what is the speed. I know that it will have Vx and it will have Vy. So I want to know what both of those are. I know what Vx is at that time is going to be equal to 11 meters per second. And then I also want to find Vy. That's going to be V naught y plus Ayt. That's going to be V naught y is 19 minus 10 times the time, which I tell you is 12.5 seconds. So 19 minus 25 is negative 6 meters per second. So if I want to find the speed, I say that the speed at that time is equal to the square root of 11 squared plus 6 squared. I get 12.5, or I'll say 13 meters per second. All right. So that's the answer for that one. All right, this block is being on an inclined plane and being pulled up by a rope with a force of 160 newtons. What is the normal force? No friction. What is the acceleration? And then if there is friction, what is the acceleration? All right, let's just assume first there's no friction. I'm going to label my forces. There's my normal force. I have a weight right here. And that's it. I have this F that's equal to 160 right here. I'm going to go ahead and sketch in my coordinate system. Realize that this angle is 60 degrees. And now let's do this with the forces. It's my normal force. I'm going to resolve this force weight into its x and y components. So here, this is going to be the force weight, which is 150 newtons. I got that 15 times g is 150. 15 times 10 is 150. That's times the sine of 60. And then here I have 150 cosine of 60. Right. That is 75 and 130 newtons. Those are the x and y components of the weight. So now, to find the normal force, I'll come back to that. We'll see. I've labeled the forces, I've labeled the coordinate system, and I've resolved the x and y components. Now the final step is to apply Newton's second law. See that the normal force is on the y-axis. So in order to find the normal force, I'll need to consider the sum of the forces in the y direction. They're equal to MAY. It's Newton's second law. AY is equal to 0, so this is equal to 0. That's going to be Fn minus 130 newtons equals 0. So that's my answer. Fn equals 130 newtons. That's the first part. The second part, B, what if there's no friction on the block? What is the acceleration? To find the acceleration, by the way, I know it's going to be accelerating up in this direction. Find the acceleration, I say the sum of the forces in the x direction equals max. That's 75 minus 160 equals the mass, which is 15 times ax. What I did there is I said this 75, that's in the positive direction. This is in the negative direction. Those are my forces. To take the vector sum is 75 minus 160. And then 75 minus 160 divided by 15 is minus 5.7 meters per second squared. That's equal to ax. Right, so that's AX. And then finally for part C, I'm going to do this in a different color so you can see it. I'm going to add this frictional force. It's going to act in this direction. That would be on this one right here, Fk. I can calculate that frictional force because I know what mu k is, and I know what the normal force is. Mu k is 0.1 times the normal force, which is, I found it already, it's 130 newtons. So that's 13 newtons. Then I can say the sum of the forces in the x direction are now different. I have a Fk plus 75 minus 160 equals max. Replace this with 13. So that's 13 plus 75 minus 160. That's minus 72 equals 15 times AX. So AX is equal to 72 divided by 15, which is negative 4.8. So that's part C. Sit on that one. Now I also wanted you to find the vector sum of A plus B. Let's just let's draw these vectors first off. I'm going to go back to my blue. Draw these vectors first. A is 25 newtons at 60 degrees below the negative x-axis. So that's the vector A. It's 25 at 60. And then the vector B is 12 newtons, so half that, and it's 30 degrees above the positive x-axis. It's 12 newtons. I didn't draw that exactly to scale, but you get the idea. Okay, so now I'm going to let's find AX and AY, and then BX and BY. Referencing the figure to help me to figure out which one is positive and which one is negative. That's going to be 25 cosine of 60, 25 sine of 60, 12 cosine of 30, and 12 sine of 30. So we'll just call that 13 to keep proper sig fig. So 13 newtons. This is 22 newtons. Okay, I'm sorry, I made a mistake here. So, okay, sorry, let me fix this. Okay, so this is AY. Right, yeah. And then this is BX. And that's BY. Okay. And then 12 cosine 30 is 10. And then this is 6.0 newtons. Okay, so let's address the signs. For the vector vector A rather, which is right here, it has a negative x and a negative y. So vector A has a negative x component and a negative y component, because this y component is in that direction and this x component is in that direction. However, the vector B has a positive x component and a positive y component. Right, so those are my x and y components. Then I can add the x components together and the y components. That gives me negative 3 newtons, and that gives me what is that? Negative 16 newtons. When I add those together, I get those, and then to find the magnitude of that new vector, this would be a plus b, the x and y components of a plus b. To find the magnitude, I would say the square root of 3 squared plus 16 squared. That's going to be 16 newtons, and then or I would take 16.3. Either one I would take is okay. And then also the direction would be well, let's draw it. So this is my y component, this is my x component. So I have negative 3 and then negative 16. So the angle theta is going to be the inverse tan of 16 divided by 3. And I get 79 degrees. So the direction is 79 degrees below the negative x-axis. Negative x-axis. We'll be looking for this, by the way. If you don't get that, you're going to get half credit for it. Okay? All right, let's go on multiple choice. Launch projectile off the platform. There's 180 meters tall. There's its initial velocity was the horizontal range. Well, to find the horizontal range, I know that x is equal to vxt. I know vx is equal to 4, but I don't know t. So I need to figure out what is t. But I know that it drops down a distance of y equal to 180 meters, or actually negative 180 meters. So I can figure out t. Say y is equal to v naught y. Excuse me, that's a subscript, v naught y t plus 1/2 ay t squared. V naught y is equal to 0 because it's horizontal. So I have negative 180 equals negative 5 times t squared. T is equal to 6 seconds, square root of 36. All right, now once I get that, I just say x is equal to 4 meters per second times 6 seconds is equal to 24 meters. How long is the object in flight? Well, look, I already got that. So that's easy. Which of these plots represent the y component of the displacement? So the y component of the displacement, it will look like C. Look, it has a small slope to start, and it increases, the slope increases in the negative direction. That describes how it changes motion. If I were to plot Vy versus T, it would look like this. It would look like that. All right. Number 4. So the projectile follows this path. Which of these statements is true about its motion? The acceleration at B is smaller than the acceleration at C. That's not correct. At both places, they have an acceleration in the y direction that's equal to negative 10 meters per second squared. The speed of the projectile is largest at point A. That would be true if it stopped right here, but it continues going down here, gaining speed in the y direction. So really, the largest is at point D. An object dropped at point A would require the same amount of time to reach the ground as this projectile. That means if I drop something right here and it goes down, would it take the same amount of time? Let's come back to that. The acceleration at point B is 0. That's not true. I've already addressed that. It's actually negative 10 meters per second squared. So I'm not entirely sure about 3, but I definitely get rid of these. So I'm now either down to D or E. So I know that we said that if I drop an object like this, that it takes the same amount of time to reach the ground as something like that. However, we also said that an object's vertical height determines how long it's in the air. So an object that follows this path is just longer in the air than the object that follows this path. Isn't that the same situation? Here, this object, it only comes to this height, but this object actually goes up to this height. So that means that it will not require the same amount of time, that in fact the parabolic path will require more time. So the answer is E. That question was difficult. You had to take several different ideas and bring them together in order to understand what the answer to that question was. Basketball is shot from a free throw range. Its acceleration is always equal to c, so 5 is c. And here, address this back in number 4, but the same height and same time. One is fired horizontally, another is dropped. They're going to have both the same amount of time. All right. Let's draw vectors 2a and b. Vector A is 3 units, so that means that this is going to be 6 units, and then b is 5 units. So it's going to be up like this. That's 5. This is 6. So I want to know the length of that vector. So I'm going to say the square root of 5 squared plus 6 squared. I think that's what, 5.8? No, it must be 7.8. Yeah, 7.8. Look, you could have gone through and gotten rid of some. You know it can't be 12. The maximum 5 and 6 would be 11. It could be this one, but they'd have to both be in the same direction in order to get 11. It could be D, except they would have to be in opposite directions to get 1. So it's either A or B, and the answer is B. Vector in the xy plane is a magnitude of 25 meters and a positive x component of 12 meters. Let me think about this. I'm going to have to add something. Hold on. Okay, I'm going to add an additional thing that will tell you that it also has a positive y component. Actually, no, hold on. I'm sorry. One more pause. Yeah, I'm going to say that it also has a positive y component. That will be what your exam says. So it has an x component of 12 and a positive y component of some unknown value and a magnitude of 25. And I want to know what this angle is. So I would say that the angle theta is the inverse cosine of Jason over hypotenuse, 12 over 25, and that's equal to 61 degrees. So E is the right answer. Number 8, yeah. And then here I have A minus 2B. That's B, so I'm going to make it go in the opposite direction. And then the resultant is that one, which is A. Certain vector has an y component, which is larger than its x component, and both are positive and non-zero. Okay, so the y component is bigger. So here's my x component, there's my y component, just relative to one another. That means that the angle, this is 0 degrees, this is 90 degrees, this is 45 degrees. This angle is between 45 and 90. So D is the right answer. All right. Pulling a block on the table, the friction F. As the frictional force as which of these statements is true? If the block is accelerating, then F is larger than F. That's true. The sum of the forces in the x direction equals MAX. The F minus F equals MAX. In order for it to be accelerating, that has to be true. The normal force is dependent on the frictional force. That is not true. While it is true that the frictional force is dependent on the normal force, the opposite is not true. This is the independent variable, and this is the dependent variable. The block is moving at constant speed. F equals F. That is true, that it can have, if F is equal to F, that means the sum of the forces equals to 0. That means that the acceleration is equal to 0, so V is constant. Frictional force is dependent on the mass of the block. That is true because the mass of the block will change the normal force and that will change the frictional force. It looks like we have 1, 3, and 4. C. Friction does act on this cart on a horizontal table. We can say about the acceleration of the cart. In this case, the cart's acceleration will be opposite the direction of its velocity. So if it has a velocity in this direction, it will have a frictional force in that direction. That'll be the only force, so the acceleration will also be in that direction. All right, consider this object. It's accelerating up. It has a frictional force. Let's write all the forces on here. So here's my frictional force. I'm going to go ahead and do the weight, FW cosine of 60, and then FW sine of 60. And I'll do my normal force, Fn. Fn is equal to Fw. Nope. Fn is equal to this, Fw sine 60. Fw cosine 60 plus F, Fw cosine 60 plus F minus big F is equal to max. That's correct. Fn minus Fw sine of 60 is equal to 0. That's correct. And Fk equals mu Fn. Yes, that's correct. That's just generally correct. So 2, 3, and 4, A for 13. I just do want to point out here that when we calculate this, if we were to put in all these values for Fw, Fk, and F, that this would come out to be a negative acceleration. That would be a negative value. But when I put it in here, I'm not going to write in the negative in the equation. It will work out to be negative if the forces are all correct. Okay? Block of mass M rests on the floor. It's falling downward. So imagine this elevator, and it's accelerating downward. And it's accelerating downward at 10 meters per second squared, which is equal to the acceleration due to gravity. So if we can imagine, then, here's the normal force. Here's the weight. Fn minus Fw is equal to may. Fn equals Fw plus may. That's equal to m times 10 meters per second squared plus m times negative 10 meters per second squared, which is equal to 0. In short, this object is in free fall, so it has no normal force acting on it. It feels like it's floating. It's weightless. That's what it means to be weightless. All right. Oh, where were we? Okay, yeah. It's one of the harder questions on this test. What is the force? I have this 20 Newton force in this direction. It has a 2 kilogram block, so I have a weight equal to 20 newtons. I have this additional force right here. I don't know what this force is. And there's a frictional force that's acting on this block. And I want it so that the block doesn't move. That is that AX is equal to 0. In order to have AX equal to 0, I have to have the sum of the forces in the X direction, which are Ft minus F, S, this would be a static frictional force, equals to 0. So I can calculate Fs then. I have 20 newtons minus Fs equals 0. So Fs equals 20 newtons. Then, oh, I'm sorry, I also have the normal force right here. I'm going to redraw this a little bit just so that we can see these vectors a little better. Ft, F, sorry, I was getting a little ahead of myself right here, but it'll make sense here in just a second. Fn in this direction, and then I have F, that's the force that you're pushing down on, and then in addition this 20 Newton force. I want to know what this force is. If I can figure out the normal force, then I can determine this force because it'll just be the normal force minus 20. So here I have the static frictional force that allows it to be not moving. Then I also know that Fs is equal to mu s times the normal force. And so that's 20 equals 0.1 times Fn. So Fn equals 200 newtons. So this force is equal to 200 newtons. That means if I do the sum of the forces in the y direction, which are equal to 0, that would be 200 minus F minus 20 equals 0. So F then equals 180 newtons. All right, let's see. Apply a horizontal force to a 50 kilogram mass and it accelerates at this rate. Let's draw a picture. I get this 500 newtons because it's a 50 kilogram mass. That's the mass. So the weight is 500 newtons. And I have a normal force, Fn, is going to be also equal to 500 because there are no other vertical forces. I'm just going to bypass that. I know these two forces have to be equal. And then there's also a kinetic frictional force. Now, if this object had no friction acting on it, the acceleration would just be F over m, 100 newtons divided by the mass, which is 50, would equal to 2 meters per second squared. If there was no friction, it would be accelerating at that rate. But there is friction, so that's not true. My acceleration is equal to 1 meter per second squared. I can look at the sum of the forces in the x direction. That's 100 newtons minus Fk equals max. And I know my normal force, so I can figure out Fk. That's 100 newtons minus Fk is going to be mu Fn. That is, actually I don't know that. I'm going to write in mu k times the normal force, which is 500 newtons. Is going to be equal to the mass, which is 50 kilograms, times the acceleration, which is 1 meter per second squared. So now I can solve this for mu k. Negative mu k times 500 equals 50 divided by 100. Or excuse me, 50 minus 100, or negative 50, and then divide both sides by 500, negative 500, and I get 0.1. All right. This is elevator ascending upward, so it's similar to the one we had before, except I just want you to calculate it. Actually, you can probably reason out what the tension is going to be because the weight of this object is equal to 100 newtons. We have a force weight equal to 100. And here, whereas before it was ascending downward at 10 meters per second squared, here it's ascending upward at 10 meters per second squared. So you can probably guess, maybe, that I'm now going to have twice the weight since I'm going up at an acceleration of 1g. That's what it means when they say, oh, it's 1g, 2g, 3g's. It's a multiple of the acceleration due to gravity. That if I'm accelerating upward at 1g, then it doubles the tension, or the apparent weight, which is this tension in the string. But let me show you how to get that. I would say the sum of the forces in the y direction, that's Ft minus 100 newtons equals may. So Ft equals 100 plus may. That's 100 newtons plus 10 kilograms times 10 meters per second squared. That's equal to 200. You have three equal masses with mass m. Exert a force on one of the masses and get acceleration of a. Now combine the three masses and exert the same force. So if I exert a force on mass m, I'll cause acceleration a. What if I exert the same force now on a mass that's 3m? Well, F equals ma, or F equals 3m, because I'm now tripling the size of that mass. So I'm going to get now A is F over 3m, or whereas before it was A equals F over m. So I'm getting 1/3 of the original acceleration. 1/3 of the original acceleration. So 18 is A. You can sort of make that out, right? I mean, if I kick a little pebble and then I kick a big stone, the pebble's going to accelerate more quickly, right? Whereas the big stone, which has more mass, doesn't accelerate as quickly. And it's dependent upon the multiple of mass that you have. All right, this is one of the more difficult ones. What is the coefficient of kinetic friction here if it accelerates to the right at 2 meters per second squared? I'm going to redraw this with all of my vectors. This is Fk. I'm going to go ahead and find the x and y components. It's 50 sine 30 is 25 newtons, and then 50 cosine 30 is 43 newtons. And then the weight here is 100 newtons. Yeah, that's all that we have. And I want to know the coefficient of kinetic friction. Oh, I have one more force. I didn't put this, I'm sorry. Fn. So I know that the coefficient of kinetic friction is the ratio of Fk and Fn. Just get that from this equation. Fk equals mu k Fn. And solve for mu k. So I need to find Fk. That's easy. Fk is equal to 43. See, I just look at these forces and know that they... Oh, wait, no, I'm sorry. That's not that easy. Sorry. I do the sum of the forces in the x direction is equal to max. So that's 43 minus Fk equals 10 times ax, which is 2. So Fk is equal to 43 minus 20, 23 newtons. Yeah, 23 newtons. And then I can find my normal force, Fn, by looking at the y forces. Some of the forces in the y is Fn plus 25 minus 100 equals 0. So Fn equals 75 newtons. Then my coefficient is going to be 23 over 75 is 0.31. C. All right, what is the coefficient of static friction between the block and the inclined plane required to keep this block in place? We've done this, so let's sketch in our forces, Fn, Fw, Fs, and now I can draw these. This is going to be Fw sine of 60. Let's go and put in these values. Fw sine of 60, that's 100 sine of 60. 87 equal to 50 newtons. So since this is staying in place, I know two things. Sum of the forces in the x equals 0, and the sum of the forces in the y direction equals 0. That means that Fs is equal to 50, and Fn is equal to 87 newtons. And so mu is going to be 50 divided by 87. 0.6 or 0.57, 0.6. All right, I think that was it.